Okay, so we're back, and we're going to talk about the first trigger. This is state duration. Um, this is fairly straightforward. This basically looks at the how long a particular agent has been in its current state, and then if it's been in that state for longer than, in this case, 1 second, it's going to switch to the next state. This is fairly straightforward. If one of the things here that's kind of good to take a look at, I'll hide all attributes, is the state duration attribute. And this is basically what it's keying off of. So it looks at that and it basically does a comparison with this value. And if it's greater, it's going to start a transition. It'll trigger a transition. And in this case, it changes from walk to run. Not too much. That's pretty much it. So that'll be the end of this video. All right. The next trigger type that we're going to look at is object bounds. So for this example, you can see that there's two components. There's this, which is a piece of geometry, in this case a pig's head. This is going to be our bound object. And then there's the actual DOP network itself. So what I'm doing here is I'm basically using a trigger, and I'm changing from the if one of the agents goes into this bounding object, it's going to change states. So it's going to change from a walk to a run. So let's take a look at this. All right. Actually, there's some important things here. One of the things is we have to specify the source, right? So you can, in this case, I'm using SOPs, so I'm just pointing to a piece of geometry that I created out here. Fairly straightforward, but you don't necessarily have to do that. You can use DOPS data as well. So if you had something like a simulated object, and once that character was inside that simulated object, you wanted to trigger some sort of behavior, you could use this. This is not the same though as that would not be the same as an RBD Impact, which I have that example, and we'll be showing that to you in another round or another video. So yeah, we can just take a quick look at this, and I'm going to play forward here. And when these agents basically get inside the pig, they start running. And the other agents don't ever make it inside, so they don't run. Pretty straightforward. Not too much to report here. So great. All right. So the next example that we're going to talk about here is object attribute. So let's turn this on first of all. So there's a piece of geometry here. The piece of geometry has an attribute. Let's take a look inside. So I have a line, and on that line, I'm creating an attribute called test. And basically, if the point number, if the frame is greater than one of these point numbers, it's going to turn this test value to 1, or test attribute to 1, and otherwise it'll be a value of 0. And so as I scroll forward, we can see that I'm also setting the color to the test value just so we can visualize it easily. And you can see it's turning red. We can also verify this in the spreadsheet. Here's our test value, and there we go. Okay, so this is the geometry we're going to be referring to for this one, and I'm going to dive inside this network. High points. Okay, so in here on the trigger, the type is object attribute, and then you get to specify where you're sourcing from. It can either be inside SOPs, which is probably the most common, or DOPS data. So if you have some sort of dynamically influenced or created a geometry that you've created within your simulation. You specify the path in the case of SOPs, so just the end here. And you name the attribute that you want to do your comparison again. So, or that you're testing for. So in this case, I called it test. And then you specify a search radius. So in this case, I made the search radius 5, which basically corresponds to the radius of this sphere. And as a matter of fact, I made a channel reference, just so it's really easy to visualize when these agents should become active. And then comparison values. So basically, if the test value is greater than 0, then the agent should be triggered and change states. So let's just play this forward and see what we got. So you can see this. Let me change this to dark so it's maybe a little bit more easy to see. I'll zoom in. So we start off here, and this agent pretty much immediately changes to a run cycle. These agents, they change very quickly as well. This agent won't, because it's never going to fall within that radius. Let's see what happens with these guys coming up. Yep, they both get triggered, and so on and so forth. Let's see. Yeah. So fairly straightforward in terms of how it works. Yeah, should be good to go there. Okay, in this video we're going to be talking about the object distance for the trigger type. Yeah, so here we're going to be using this small sphere. That's going to be the geometry that we're referring to. And let's dive into the dot network here. I'm going to escape, go back to the first frame. All right, so let's take a look at what we have. Here we have our trigger. And once again, the type is set to object distance or position. We're going to source this from a SOP. Again, you can source it from DOPS data if you want to. The SOP path is distance from object, which is basically just this right here, so polysphere. And you have choices, so you can say find the distance to the centroid, which is basically the center of this object, or to the closest point on the object. So the centroid would be the center, and then the closest point is like, the closest point on the object. There's this comparison value. So what I'm saying is if any of these agents is within 10 units of this object, then activate the trigger. So one gets activated and starts running. The other one gets close enough. There we go. And this guy gets picked up, as does this one. And that last straggler right there. Fairly straightforward, fairly simple. All right. So the next type that we're going to look at is raycasting. Again, we're going to use a piece of reference geometry. So this pig's head is what we're going to be casting our rays against. Groovy. And so here we're going to be raycasting. We're going to be using the SOP object as a reference. As I mentioned before, you can use DOPS data. And it's basically going to fire out a ray. And if it hits something, then it will activate. You get to specify the length, and you get to specify what type of behavior. So if it hits something, trigger the behavior, or if it doesn't hit something, then trigger behavior, a different type behavior. yeah, so that's fairly straightforward. I'm going to take a quick look in the help here because I'm just curious about the type. Object distance, Raycast. Yeah, so it's been a while. I believe that where the ray is actually cast from is from there's a point, right, that defines the agent. So if we, excuse me, come back and look at our crowd source here for a moment, turn on point display and point numbers, you'll see that there's a point at the bottom. And if memory serves, that this is where the ray is actually being cast from. So that's something to keep in mind when you're putting together this raycast. It's limited to the position of this point. I'm not 100% sure, but I believe that that's the case. So, yeah. Anyways, let's see how it works. So it gets within distance, it's firing the ray, and then once that ray gets within, 10 units of this pig, it hits it, and the agent can run. Groovy. So that's raycasting. One of the things to kind of keep in mind here is this is, fairly limited, right? It's firing at a single ray from a point at the bottom of the agent. Which is fine for simple things. If you wanted to do something like more advanced, like I don't know, find the position of the head and then fire out rays, multiple rays, so I don't know, like you could 10 rays, 20 rays, 100 rays from, say, its head, and have them cast out into the scene, and if 50% of those rays hit something, do some different type of behavior. That's not something you'd be able to do with this type of raycast. For that, you'd want to go to VEXpressions, and we'll talk more about VEXpressions in a later example, but I just kind of wanted to make you aware that it's kind of a limitation of how this works. But there's no reason why you can't make something a little more custom, a little more intricate with VEXpressions. All right, the next trigger type that we're going to be looking at is particle speed. So this one is fairly straightforward. We can come in here, take a look at the crowd trigger. The type is set to particle speed, and you have this comparison for if the speed's greater than this, then do something. You have the option to, make it angular speed, which is like rotation. Yeah, this is fairly straightforward. There is something worth noting here that is actually more important than this trigger behavior, and it's what's happening over here. This is a little bit of vex on this walk state, and if you've been following through all these videos, and you started at the in-place animation and went through locomotion. In the locomotion section, I mentioned that I'm going to talk about altering agent speed, and I'll talk about that in one of the trigger examples. And this is the example. Basically, what I have here is I have a fit expression on the frame. And so if the it's making this multiplier variable, and so if you're from the first second to the second second, change this multiplier from 1 to 2, and then I'm taking this and I'm basically changing the clip speed multiplier and the locomotion speed multiplier. And so these are two attributes. Well, actually, my apologies. These are two parameters that live on the crowd state node, and we're basically scaling these. You'll notice that there is no, this is a little out of the ordinary here. There's no type declaration at the beginning of these, containers, or whatever you want to call them, containers. There's no type declaration. There's no kind of at terminology to indicate that they're an attribute. Basically, this is an indicator that's manipulating a parameter that exists on the node. So in this case, it's increasing the clip speed multiplier and the locomotion speed multiplier, which in effect is going to make the walk cycle increase speed by a magnitude of 2, right? So it's going to accelerate this after the first second. So if you want to do something like within a particular state, vary the speed of that state, this is how you do it. So if you wanted to say like randomize it for a particular state, instead of using at frame here, what I do is like rand and use ID as a seed and have that drive this like multiplication value and then have it applied. So that's basically how you adjust speed. So anyways, so what we're going to have here is we're going to have some agents that are walking, and they're going to start moving faster after 24 frames until they reach 48. And then at that point, around 48, they're going to be moving twice as fast. And because of that, the crowd transition will be triggered. Well, it may be triggered before that, but somewhere within this 24 to 48 region is when you should get this transition. So, and there you go. So, yeah. Let's turn our real playback. Yeah, so you can see if we play that back again, you can see these agents start to accelerate and walk faster. And once they do, there they go, and bam, the run cycle picks up. So that's how that works. So this is a really important concept, and is useful beyond this example in this crowd trigger. So keep this in mind, and also keep in mind that this is where you can find this, so that if you're working and it's not something that you remember necessarily off the top of your head, you'll know that it's in the help and you can go refer to it. Okay. And that's the end of particle speed. Okay, so the next example we're going to be talking about is, or the next trigger type we're going to be talking about is particle proximity. So if you dive into here, and let's take a look at what we got. So over here on the trigger, the type is set to particle proximity, and then you have a search radius called, and that's basically it. So if we and there's this parameter here for ignore in the same group, and I believe, let me just take a look at the docs for that. So ignore particle or agents that belong to the same group. So let's just see how this works with that turned off. So the agents that are close to each other basically get triggered, and they shift to the run state. So, and if I turn this on, nothing happens because these agents are all in the same group. So you don't get any sort of change in behavior. So yeah, just again, see the behavior there. Perfect. Okay. Yeah, and that's pretty much all there is to say about particle proximity. Fairly straightforward. Okay. So the next trigger type that we're going to look up is the particle attribute lookup type. And here we have a setup. We have an agent that starts off in a neutral pose, switches to a walk, and then switches to a run. So the way that this works is the initial trigger here is fairly straightforward. This is just managing neutral to walk and the transition between those. And this is basically just based on time. So it's got after 1 second, and then it has a random offset of 0.5 to kind of add some randomness to each of the agents. And then here it's got a particle attribute lookup. So it's going to look up an attribute that I specify and then do a comparison against that attribute. And in this case, if it's greater than this value, it'll trigger the next behavior. In this case, the attribute that I'm looking up is state duration. So, you can come on to, you can check this attribute and look at it, and there it is, state duration, right? And this is going to kind of give you an idea of, how long each agent's been in a current state. This is going to be evaluating for agents that are kind of in the walk state, right? And and are looking to change to the next state. So that's kind of when this is going to kick in or take effect. Yeah. So if we play forward here, we have we start off, and some of the agents start walking, but others are not. They're still in this kind of neutral pose. And then they pick up a little later. And then some start running, right? And they start running. And they start running, in essence, after, the state duration has exceeded this value. So these guys, they've been walking a bit, their state duration increases beyond a certain threshold, and then bang, they start running. Now, I did this example using space duration or state duration as the attribute I wanted to do a comparison with. I just did this because it's easy and convenient and very, very simple to understand. It doesn't have to be this attribute. It can be any attribute you want. And there are a ton of attributes, on an agent that you can kind of query and look at and use to kind of drive this. But, the way I've created this, in essence, it's, functionally the same thing as this example, state duration. The only difference being that in this example, it's doing the comparison with state duration, under the hood and automatically. There's more flexibility when you use this operator because you can use any state you want or any attribute you want and do a comparison with any attribute you want. So yeah, that's it for this example. All right, so the next trigger type we're going to be looking at is particle attribute comparison. So let's dive into this network and take a look at what we're doing. So you can see I have some notes here to kind of give you a little bit of hint of how to understand this. The best way to kind of understand this is start by bypassing these nodes here, so you can kind of visualize what's going on. So yeah, we have here we have this kind of initial trigger, and I'm using a little bit of Vex here, nothing too complicated. And what I'm doing is I'm triggering a state change from neutral to walk. So let's take a look at what it's doing. Basically what I'm saying is if the position of the agent and X, so I'll zoom in a little bit. So along this axis here is, less than 5 or greater than -5, then trigger those, make those agents walk. So let's just push forward here. Great. So you can see we got 3 agents that are kind of within this boundary, right? And the rest remain in their kind of neutral state. Okay, so that's fine. Then over here, we're doing another transition from neutral to walk, but we have something extra, a different type of trigger that's kind of overlapping this one. So this one, what we're doing is we're saying, look at the agent speed, and if the speed is greater than, if this, and search within a particular radius. So let's take this agent here. It's going to be looking in a radius of 10 units around it. So imagine a circle or a sphere within 10 units, and it's going to be looking at all the agents that fall within that circle. And if one of those agents has a speed that's greater, an agent speed, that's an attribute, and you can look this up. Geometry, high attributes, view agent speed. There you go. So if if it has an attribute called agent speed, and if any of the agents surrounding this kind of the agent we're currently evaluating has a speed that's greater than the agent we're currently working on, if that happens, then the event has been triggered, and we can switch from neutral to a walk state. So I'm going to bypass these again and just remind you what this looked like without this branch. So we got 3 agents, right, who are walking. Now I'm going to unbypass this again, and we're going to rerun it. Okay. So let's see what happens. I'll zoom in a bit. These 3 guys, we expect them to start walking, but then these guys start walking as well. And they're walking because there are agents that are moving faster than them within that 10-unit radius. So they start moving, which causes these guys to start moving. It's a cascade effect, right? And then because these guys are moving and then they're within the appropriate radius, all of these guys start moving. Now, if we look at it on the opposite side, nothing happens. And the reason why is because this agent never comes within 10 units of this agent. If it did, then at the very minimum, we'd expect these 3 guys to be triggered. Maybe this guy, because it might be within 10 units. But as it stands, all of these guys end up getting activated, but they get activated in a kind of this cascade effect, right? So these 3 guys are what are being transitioned by these operators, right? These guys in the middle. And then all of these guys get triggered, in a kind of one after the other as this gets evaluated. And that's how that works. So, but yeah, very important to kind of bypass these nodes, get an appreciation for what it does, and then unbypass them. That's really the way you're going to be able to visualize what is going on here. All right, this next example is fairly straightforward. It's just time. I'm not going to spend much time on this because we've already seen this in a couple other examples. Yeah, so here we have our trigger operator. Before I started this video, I actually noticed a little bit of a problem with it. The comparison is, well, let me describe what it does first of all. So this is supposed to trigger a transition based on time. This is time in absolute units, not anything related to the agent's current state or anything like that. So strictly like what the global unit of time is. You get to choose frames or seconds, and then there's a random offset as well as picking the playback time where you want the transition to occur. One problem I noticed with this example is I actually have this the wrong way around. This is less than, so if the value, this is going to be triggered immediately because the current time is less than 5 seconds with a 0.5 random offset, so it's less than 4.5 seconds. These guys should start running immediately. And if we play forward, that's, I have another network display. That's exactly what happens, is they just start running immediately. So to make this like a little more meaningful, I'll change this to greater than and 2, and I'll make a note that I made a little error here in this the example file, and hopefully that'll get updated in the help. And now, we should see these guys walk for a bit and then start running. And there's a random offset, so they all should start running at the same time. There should be a little bit of leeway. Yeah, so you know what, I'll exaggerate that a little bit more. I'll change this to 1, so it's a whole second. Okay. So they're walking. Now somewhere in this region we should start getting some, yeah, and we're starting to get some agents who are running. And there you go, somewhere. There you go. And because the random offset is, 1 second, I think it's either direction. Eventually they pick up and they all start running. Okay, so fairly straightforward. I'll fix that and hopefully it'll make its way back into the build soon. Okay, next example is fairly straightforward. Not much to it. This is just using an animated parameter. It's just like it sounds. So come over here to this trigger and animated parameter. And so basically I've just made a little expression in here. So if the frame number is greater than 15, trigger the transition. So these characters are all kind of in a neutral state or neutral pose, and then once it exceeds 15 frames, we start to see that transition. Really, really, really basic. Not much to it. So this is good though if you're, want to kind of trigger some sort of behavior in a really art-directed way. Like if you have, your supervisors like, hey, I want you on this frame, I want these agents to perform this behavior. You can, do this in a very kind of direct way using this operator. And that's the end of this video. Okay, the next thing we're going to talk about is the RBD Impact data type for the trigger dot. I could dive in here, see what we're working with. So here we just have some agents that are walking, and I also have a RBD object, which is a sphere. That's just being defined over here in this node, and it's just a sphere with a packed setup and DOP import, nothing too fancy. Yeah, and so creating this is fairly straightforward. In order to create this RBD object, I think I just what is it? I think I probably just used a what did I do? RBD packed object is in essence what I made. So yeah, and it just connects over here to this merge and gets merged in with the rest of the simulation. And it gets picked up by this bullet solver. And in essence, what happens is when this object hits one of the agent's going to transition to a different state, in this case, ragdoll. So you could have it change to a different state if you wanted to, but ragdoll is kind of the most obvious candidate. So play forward here. And you can see the sphere comes and it hits this one agent, and he goes into a ragdoll state, and the sphere keeps rolling. And that's it. Pretty straightforward. So other than adding your RBD object and setting up your trigger with RBD Impact. There's an impact threshold, which, if I remember correctly, kind of sets a value in terms of how hard the agent has to get hit before they go into the trigger goes into effect. But other than that, it's fairly straightforward. So, yeah. Okay. So in this this video, we're going to talk about VEXpressions, which is kind of the last of the trigger types that I wanted to discuss. There's an example that ships with or is from the help, but I think it's worth spending a little bit of extra time kind of digging into VEXpressions. So we're going to walk through putting some of this stuff together because I feel it's really kind of relevant. So I'm going to go back up and jump out of this kind of example HDA that gets laid down when you bring it from the help. And I've made this little network, and we'll include the file so that you guys have it and can work with it. And I'll have the start file and the end file. So you can open up the start file and follow along, and then you have the end file as well to kind of check if you've made any mistakes or kind of compare it to. All right, so I have this. This is where the work's going to get done. I have this pig's head, which is going to be we're going to use for one of the examples. And then in here, there's this network, and everything should go red. There should be a bunch of error flags and stuff like that, and that's because we have this switch node and going into a crowd transition, but we don't have a trigger. So let's create a trigger and just start with that. And there you go. Okay, so groovy. And we're going to change the type to custom expression, and we're off to the races. Okay, so there's we'll just yeah. So this is very sample, a very you can see it drop something in here automatically. So it says setting the trigger to 1 will enable, setting the trigger to 0 will disable, and by default it's set to -1. So yeah, let's do something with this. Let's set a trigger. So I'm going to do something very simple. I'm just going to go if at frame, which is the global variable for the current frame. If it's greater than let's say 24, there we go. And if it's greater than 24, I'm going to set the trigger value equal to 1, which means it should activate. Okay, so let's play this forward and see what we do. So, and there you go. So they start, changing. Okay, pretty good. But this, this is basically doing the same thing that the, time, this kind of time option. The difference is that you can, because we're using Vex, this can be very highly customizable. So I'm going to copy this trigger, wire it in. I'll go time, and I'm going to switch the input to 1. I'll also go back to the first frame, and I'm going to change this around. So what I'm going to do is I'm going to make a attribute called my underscore frame, and I'm going to set it to a random value based off ID, and I will add a fractional value to the seed here. And so rand returns a value between 0 and 1. I need to specify the type here, so I'll go int frame. And I'll do a float. That's fine. So rand returns a value between 0 and 1, but obviously, testing between frame 0 and 1 to see if, the current frame is greater than that is not particularly interesting. So I'm going to remap these values. So in order to do that, I use a fit function. So I'm going to take whatever comes out of the random, which should be in the domain of 0 to 1, and I'm going to remap that to, say, I don't know, let's go 24 to 50, something like that. So I should get each agent. So basically what this is saying is for each individual agent, give me a different random value, and then that random value should be between 0 and 1, and then remap that to between 24 and 50, and then stuff it into this attribute here. And then what I can do is very simply just go my frame. Oh, sorry, I did that wrong. Excuse me. That was silly. No, what I meant to do is here, change this comparison to my frame. So if we do that and we play forward, hopefully we should get these guys switching states randomly somewhere in the range of 24 frames to 50 frames. And that's exactly what happens. So great. So that's cool, and we're good. But I'm going to do something a little different here. I'm going to drop down another trigger. I'll call this one rand frame, and this one I'm going to do dist. Actually, I'll call this one rand dist. All right, so I'll plug that into here. I'll change my input to 2. Okay, so this is what I want to do here. Is I have a piece of geometry up here, which is this pig's head, and I want to, when an agent gets within a certain distance between the agent and this pig head, I want it to trigger a change in behavior. So let's start by changing the type to custom VEXpression. Then the next thing we need is we need some we need to point to the geometry we want to test again, and that's where this inputs becomes handy, right? So I'm going to put input 1, and I will point it to a particular SOP. And where are we? I want to VEXpression GO. grab my pig's head. Okay, so this is basically like, imagine you had a wrangle, you had, 4 inputs at the top. This is like the equivalent, except, you're going and fetching the geometry from out of the SOB context, and that's what you're going to do your tests against. Okay, so the next thing I want to do is I want to, test for distance. I want to see how far away the agent is from the pig's head. So in order to do this, I'm going to go to the help first of all. Open this up. Then I'm going to look up VEXfunctions because I have a particular one in mind. And the help's giving me a little bit of grief. I think it's because I'm using such a small screen size. So I'll just pop open my web browser and go to the documentation online, which is easy enough to do. So documentation. And 18. Search for VEXfunctions. And there we go. Okay, so these are, if you look up VEXfunctions and you bring this up in the help, basically what you get is a long, very long list of functions that will help you, do any number of things. And there are a lot of different, functions that do a lot of different things, and it can be a little intimidating. What I like to do is when I'm looking for a function or trying to get something done and I don't necessarily know what it is, I'll type in a keyword and then kind of look for it. So length 2 returns the squared distance of the vector. Okay, well that's not what I want. I want to get at the distance from something. PT line returns the closest distance between point Q, and if I don't want that, distance in a line. I'm not doing quaternions. Distance between 2 points. Nope. Distance 2. No, that's not. There. And so finds the distance of a point to geometry. So this is what I want. Now I'm cheating a little bit because I know what this function is, but I'm kind of mimicking what you as a user would do, right? You look for whatever kind of keyword kind of describes what it is you want, and then look through, search the different options, and then find the one that kind of fits. And you can click on the function, go to the function, and get a little bit more information. So finds the distance from the origin to the closest point on the geometry. That sounds great. So let's use that. Okay. So I will float dist, and I will set it to XYZ dist. And if I remember this correctly, the first input is going to be the geometry we're testing against, which in this case is considered an input. So it's the first input, which we index with a 0, because it's like with Vex, the way it's numbered is 0, 1, 2, 3. That corresponds to inputs 1, 2, 3, and 4. So input 1, we'll use a 0 to represent that, and then we need to provide it with the position of the agent that we're testing from, right? So this is the geometry we're testing against. That's what the 0 is all about, the first input. And then the agent is the current agent's position, which is the second argument, the origin. So I'm going to put v at p and go like this. And so now it's basically taking each of the agents and measuring the distance to this pig head. And then I can go in here and do some sort of comparison, right? So if dist is less than 10, then I could go I at trigger equals 1. Okay, so let's test this out and see how this works, or if it does at all. So and there we go. Now, some of these guys are running already. And as these guys get closer, they start running too. Groovy. Okay. So, that works. That's great. One of the things that might be a little bit nice is if we had, well, at the moment, this is very much the same as if we drop down a trigger. There's, this crowd trigger, and there's option for object distance, right? And so, it's like, well, why not just use this? And you totally can. The reason why this is a little more interesting is I can, once again do a random function, right? So I can do I at ID, and I can fit this. So I'm going to get a random value. Random returns a value between 0 and 1. I'm going to fit that between, let's see, 0 and 1. And I'll set it between -5 and maybe +5. And I'll put this into a float called offset. So what this is going to give me is going to give me a unique value between -5 and 5 for each of these agents. And I'm going to take that and I will just add it to offset, this 10. So now this comparison, it's going to be, distance is now going to be compared to something in the range of 10 minus 5, so 5, or 10 plus 5, which is 15. And so let's see what we get, see if we get anything different. Yeah, so you can kind of see some interesting stuff here, right? This agent back here starts running, but this guy is still walking. And it's probably because, the offset here is kind of changing, so it includes this agent, but it does. This one's offset is, probably on the lower side, so -5. It's cutting in, so the radius, this represented by this 10 plus offset, is smaller, so it's not being included, and he doesn't run. So, and eventually, you see, he comes close enough to the pig's head where it kind of falls within whatever his margin happens to be. And you see him take off. So, but you can do a lot of really interesting stuff with this. So, and if we wanted to exaggerate this effect, we could even go like -10, +10. So the range is now, -10 plus 10 is 0, and then 10 plus 10 is 20. So let's see what we get. It may be less obvious just because we have so few agents, but we'll see what happens. Yeah, so this is interesting, right? You have, this agent's running, this one's not, this one is, these ones are, right? Yeah. So, and this is something that you cannot do with this crowd trigger, or with this, set type to object distance. So this gives you, there is way more flexibility in terms of what you could do here. I mentioned in one of the other videos, like a really interesting behavior that you could, try out. And I haven't had a chance to kick the tires on this, but, would be to find the position of, say, the head and use that position. And from that position, fire out a bunch of rays. And there's a function, I think it's called intersect, that will let you fire out rays. And you can fire out a bunch of rays in a kind of cone from the head. And if it hits something, then, triggers some sort of behavior. And it would work very much like vision, So the potential here and the amount of flexibility that you have with using VEXpressions for triggers is massive. And the only thing that's really limiting you is, your imagination and experience and comfort level with Vex. So, I highly encourage you to learn a little bit of Vex and start playing with these ideas. Okay, and that's the end of VEXpressions. And if I'm correct, I think this kind of wraps up our section on triggers as well.